Okay, we'll take a look now at using those properties that we've just learned to rewrite log expressions in expanded form and also condensed forms. And so recall those three properties that we've looked at. The log to the base b of x times y is equal to, do you remember? The log to the base b of x plus the log to the base b of y, right? When we multiply like bases, we add their exponents. Log to the base b of the quotient x over y is equal to log to the base b of x minus log to the base b of y. And finally, log to the base b of x to the r is equal to r times the log to the base b of x. So those three properties you really need to have committed to memory. Now we will apply these, and we want to write each expression as a sum or difference of logarithms. And so the first one is log to the base 3 of 27x divided by y. The way you need to work these is to think about what is the argument. Is it a product, a quotient, or an exponential expression? We have a quotient. And so we're going to first convert this to the log to the base 3 of 27x minus log to the base 3 of y. So I simply applied that quotient property. Now we need to examine our arguments to see if any other property can apply. And I notice that my first argument is a product of 27 and x. I can rewrite that as a log to the base 3 of 27 plus log to the base 3 of x minus log to the base 3 of y. And finally, I want to see if I can simplify any of these expressions any further. Log to the base 3 of 27 means what exponent of 3 gives me 27? Because 3 cubed is 27, I can rewrite this as 3 plus log to the base 3 of x minus log to the base 3 of y. Now be sure when you're completing your homework that you enter this expression without any spaces and you put your argument in parentheses. Log to the base 7 of the quantity a divided by 5d squared. Here again I have a quotient. I will first apply the quotient property to rewrite this as log to the base 7 of a minus log to the base 7 of 5d squared. Now, a is simplified. I can't do anything about that argument. But notice that 5d squared is a product. So I can rewrite the log to the base 7 of 5d squared as a sum. Very important here that when I rewrite this, I would have log base 7 of a minus, and then in parentheses or a bracket, log to the base 7 of 5 plus log to the base 7 of d squared. Right, because that minus sign before the log base 7 of 5d squared is going to apply to that whole expression. So now we need to further rewrite this as log base 7 of a minus log base 7 of 5 minus log base 7 of d squared. But one other property can apply because d squared is an exponential expression. Therefore, I can apply the power property. This expression is log base 7 of a minus log base 7 of 5 minus, and now the exponent comes down. This will be 2 times log base 7 of d. So understand the three properties I had to apply. I used the quotient property initially, then I used the product property to rewrite the log of the product. Then I had to use a power property to bring the exponent down as a coefficient of the log. Part C is log to the base 5 of x cubed y to the 7 square root of n. This is a product inside the log. I can rewrite this as the sum of the log of each factor. This becomes log base 5 of x cubed plus log base 5 of y to the 7 plus log base 5 of the square root of n. But remember that the square root of n is n to the 1/2. Therefore, I'm going to write this as log base 5 of n to the 1/2. So I applied the product rule. Now I need to apply the power rule to each of these because each argument is an exponential expression. I can rewrite this as 3 times the log base 5 of x plus 7 times the log base 5 of y plus 1/2 times the log base 5 of n. Now I'm going to use these properties in the next objective to write a sum or difference of logs as a single log. So I want to apply the properties to rewrite these expressions. I have the log of 4x minus 3 minus the log of x. So I'm looking at what operation connects my logs. I have a difference of two logs, and by the quotient property, I know that if I have a difference of logs, this is equivalent to the log of the quotient. So this would equivalent to the log of 4x minus 3 divided by x. Part B is a log base 2 of z plus 4 times log base 2 of y. The first thing I need to do is if I see a coefficient of a log, I need to use the power property to take the log to the exponent of the argument. Therefore, this becomes log base 2 of z plus log base 2 of y to the 4. Now I see that my logs are separated by a sum. The product rule tells me that this is equivalent to the log base 2 of the product of those arguments, z times y to the 4. Part C is 2 times log base 4 of x plus 1/3 times log base 4 of z. I see a coefficient of the log, so the first thing I need to do is take the coefficient up to the exponent. So this becomes log base 4 of x squared plus log base 4 of z to the 1/3. Well, a sum of logs is equivalent to the log of their product. This is equivalent to log base 4 of x squared times z to the 1/3. And finally, I can just simplify this in one other way. I can rewrite z to the 1/3 as the cube root of z. So I have log base 4 of x squared times the cube root of z.